Hello and welcome back to The Rationalist. To those of you who follow me, you've probably been wondering, where's he been for these last few weeks? I haven't seen any new videos. And the reason is, it's kind of on purpose. Most of the things that we've been talking about border on politics or have some touch into politics at some point. And aren't we all tired of politics right now? I am so glad the election is over. Doesn't matter if your candidate won or lost, the election is over. Thank heavens. A little tired of it. So today I'm going to stay away from politics. Again, I don't get into that purposely, but today we're going to change and we're going to talk about science. And I'm hoping you'll find this of interest. This is all going to tie together at the end, so stay with me through this, all right? Thank you. Let's start by talking about invasive species. We certainly have seen this type of thing happening in our area, but it happens all over the world. Probably the first way I can imagine that it happened was somewhere out in Polynesia. Coconut rolled down the beach into the water, and the waves picked it up and took it all the way across the Pacific Ocean to California or Mexico. And a palm tree grew. That was an invasive species at one point. You think about places like Australia, which have such unusual animals because other species weren't able to get from one continent to another. But some of these species have been worse than others. So as civilization advanced, you got boats or rafts, and people now could boat across an entire continent. Well, when you do that, then you start to have things in the hold like rats and snakes that can bring invasive species in this case animals that harm the ecology of wherever they land. And with small boats that go in one body of water, you take them out of the water, you put them on a trailer, you take them to another one. Well, now you've got things like milfoil that will clog up water where it wasn't. And I understand that the zebra mussels, which are in the Northeast now, came over first on a Russian boat that had them in its ballast tanks and released the ballast here and spread it that way. So these are how, as civilization advances, things become worse with invasive species. Excuse me. Now think about planes, trains, things like this that can bring things faster. It's harder to keep things out. Now, here we've been talking about animals and plants, flora and fauna, if you will. But now let's talk about microbes, parasites. We think, we don't know for sure, but we think that Christopher Columbus, and other explorers brought disease from the old world to the new world and wiped out entire civilizations in Central America. Now think about China with the recent COVID virus, and that's spreading around the whole world. With the interconnectivity of the world these days, it's harder and harder to keep these things out. So as science advances, technology advances, travel advances, it's harder and harder to keep these invasive species out. Just to give you a couple more examples, in this area, in the Finger Lakes area, we see emerald ash borers, which are destroying trees. And it started years ago with things like Dutch elm disease, which wiped out all the elm trees. And are you aware that until about 50 years ago, there was no rabies in animals in the Northeast? But some hunters went to Virginia and got a bunch of raccoons and brought them back so they could hunt raccoons. And those raccoons had rabies, and it spread to the Northeast. So these are examples of the things we do by mistake, but how it affects us. Now I'm going to shift gears for a little bit, but please bear with me because I am going to come full circle, okay? So as our knowledge of physics and the world around us has advanced, we've made exciting discoveries that have really changed things. Some of these have been very beneficial, just as an example in medicine, or as in medicine with being able to create vaccines so quickly for viruses, like we're seeing with the virus right now. And then there's the negative side, nuclear weapons. So there are pluses and minuses, but we continue to learn more about the world around us and make scientific advances with this knowledge. But there's one thing that has held constant throughout this time, for the last 80 or so years, and that's the discoveries, theories, and equations of Albert Einstein, a true genius. And a way to make your mark in the world of science today, if you're a researcher, you work for a university, whatever, is to disprove a theory of Einstein's. And the interesting thing is nobody can. Nobody ever has. We keep finding more evidence backing up his amazing discoveries. So as we make discoveries that go from the very, very small subatomic particles to the incredibly large, studying space and time, all these works of Einstein's continue to hold up. We cannot disprove them, and so it seems logical to think that these things will continue. Well, one of the basic tenets of Einstein was that nothing can travel faster than the speed of light. So light or other similar wavelengths can travel at that speed, but nothing else can. And in fact, it's very difficult, other than if you're light, to even approach the speed of light. It's difficult. So this makes travel in our planet around the world fairly easy. We can go what we consider fast. But when you now talk about things in solar systems or universes, we're very slow. We cannot go fast enough. We can't approach the speed of light. About now, you're wondering, why did I bring this up and how am I going to tie these things together? Again, please bear with me, I will. Okay, right now we're currently working on sending people to Mars. We've sent people to the moon. We've orbited the Earth. But now we're thinking about actually making colonies on Mars. Well, when you travel in a spaceship to the moon, it takes a few days. To go to Mars, assuming that Mars and Earth are in the closest place to each other, it'll take you about 9 months to get there. 9 months. Now think about this, the rigors of the cold vacuum of space. You've got almost absolute zero temperatures. You've got radiation. You've got no oxygen. You have to bring all that with you. How do you possibly travel 9 months to get to Mars? Now, we can do it, but it's not easy, and I think you're going to see a lot more failures than successes, at least to start. But let's suppose that we work that stuff out. Okay, we go to Mars. We've looked around our solar system pretty well, and we know that there's no intelligent life anywhere, and maybe not life even unintelligent anywhere in our solar system. So to find other intelligent life, which would certainly be interesting, we're going to have to travel out of our solar system. To go to another solar system takes many, many light years. And to get to a place where there's intelligent life will probably take millions of light years. That's why when we look at the stars in the heaven, we say the light you're seeing there was created millions of years ago. It's not what you're seeing right now. Happy stuff. What that tells us is we will probably never be able to travel anywhere where we will find our intelligent life, nor will other intelligent life be able to travel far enough to reach us. So for better or worse, we're probably never going to live in the science fiction of Star Trek or Star Wars. It might be fun, but it probably wouldn't be beneficial, and that's what I'm coming to. Okay, now let's tie these two discussions together. I'm going to do this by starting with a question. Do you believe in the evolution of species? Do you believe in God? Do you believe that there is a master plan for life on Earth, or at least for humanity? Whichever of these you might believe in, I have a theory for you. I think there is a plan. And that is that in an infinite universe, there must be an infinite number of life forms. It's so hard for us to get our hands around the ideas of infinity of space and time. But if space really goes on forever, if it's infinite, and time also, then there have to be more intelligent life forms out there than what we know here on Earth. Now, let's go back to Columbus and him spreading disease from the old world to the new world. If we were able to travel, or any species was able to travel many, many light years, meaning you'd have to travel faster than the speed of light, to find another intelligent civilization, wouldn't we spread disease? Wouldn't one of those species completely wipe out another through disease? Probably. We've got nuclear weapons. Who knows? We might develop things that are even worse than that. Man always brings war wherever he goes. Wouldn't, as species intermingle, wouldn't they bring war to each other? Through disease, through war, we would be wiping out entire species, maybe entire solar systems. Therefore, it's in the best interest of all species and all life in the entire universe not to be able to travel faster than the speed of light. Maybe there's a plan. Maybe that's part of it. Let's assume for fun that there is an omniscient being, one all-powerful creator who created life. He might think that as life evolves on one planet, it's an experiment to see what can develop. Maybe that life is destroyed, but it's okay because there's an infinite number of other life forms, and so the experiment takes different shapes and has different results. However, if we were able to travel to each other, then we would interfere with the life species and its evolution in other places and potentially wipe it out. So the laws of physics, which hold that there will never be faster than light travel, are a security blanket for all life in the universe. Was it created this way on purpose? Did it evolve on its own? I don't know. But it's kind of fun to think about, isn't it? And along those lines with fun, here's one more thought for you. The Big Bang Theory. Based on our observations of the universe, I believe in the Big Bang Theory. This means that after trillions of years, the universe will basically collapse upon itself, and then the Big Bang will happen again. And this has probably been going on for all eternity. We're aware of it happening once, but it's probably happened an infinite number of times and will happen another infinite period of time. So the experiment of life restarts every trillion years, approximately, give or take a few billion. And so whatever happens with life, it reaches a certain point, and then it all goes away and it all starts again. It doesn't make humanity seem so special, does it? These space-time questions make us feel rather small. Anyway, I hope you've enjoyed these thoughts and staying away from politics for a week. We'll see if we ever get back to that. But thank you for your time. I'd be very interested in your thoughts, so please leave a comment, let people know about The Rationalist, and have a great day. Thank you.